So today we're going to start our pre-cal lesson on page 45, and we're going to be in the right-hand column. We're going to look over the text before we start doing the math problems. And so today we're going to learn about this thing called the law of sines. So everything we've been doing up until this point has been a right triangle. We did SOHCAHTOA before we went on spring break. All of the Pythagorean or the trig functions we were using, sine, cosine, tangent, cotangent, secant, cosecant, we're all based off right triangles on the unit circle. But now we are going to move on to oblique triangles. And an oblique triangle is any triangle that does not have a right angle. So first of all, I need to make sure you guys remember how to label triangles properly from geometry. We're going to use capital letters for angles and lowercase letters for sides. So let's write a little note. Capital equals an angle, and the lowercase is going to be a side. And they're going to be across from one another. So if I call this right here angle A, then across the triangle has to be little side A. And if I call this angle B, then across the triangle has to be side B. And if we call this one C, then across the triangle has to be little c. So now that we know how to label a triangle, we can move on to the law of sines. And all that is just a ratio. So it says that if I'm going to use the law of sines, there's two cases where I use it. I use it when I have two angles in any side, which is an angle, angle side, or an angle, side, angle. And then this one's a very special case, which we're going to talk more about later this week, but it's the side, side angle case. So here is what the law of sines says. It is a set of ratios, and you can write it either way. You can write it with the angles on top or the sides on top. It doesn't matter, but whichever one you pick has to stay intact. So on this one right here, the sides are on top, and then it's always on the bottom sine of the angle. On this one right here, the sine of the angles are on top, and on the bottom I have my sides. And you can do one or the other, but we're not going to interchange them. So what you need to do before we move on to the other column on page 45 is you're going to need to have your calculator. You can have your calculator. There's a link on Canvas where you can download the calculator and put it on your computer, or you can actually have a calculator in your possession, and I'm going to use the ones that we have in class. So the first problem on page 45 says that I have a triangle that big C, the angle C is 102.3 degrees, angle B is 28.7 degrees, and little b, the side B, is 27.4 feet. Find the remaining angle and sides of the triangle. Why must you use law of sines? Well, we have two angles and a side, and I'm going to draw you a picture so we can see why we're going to use the law of sines. So I'm going to, since one of my angles is obtuse, I'm going to draw an obtuse triangle to the best of my abilities because we all know I can't draw. And I'm going to call this angle in here my 102.3 degrees, which we called C, which means over here this is going to be side C. And then it doesn't matter what we call angle B. I'll call it right here angle B, 28.7 degrees. And that means across the triangle from angle B has to be side B, 27.4 feet. And if you remember on page 45 in the notes, it says if we had an angle, angle side, or an angle side angle, we'd use law of sines. In this case right here, we have a angle, angle side case. So we're going to definitely use the law of sines. And the way that I learned to do this was that if I had a complete ratio, then I knew to use the law of sines. And what I mean by a complete ratio is I have a little side B and an angle B. Anytime you have one complete ratio, you can use the law of sines. So to do the law of sines, I'm gonna find side C, little c first. So it doesn't matter which way you write it. I tend to write the sides on top, so I'm going to use the version that says sine sorry, I need to put my b up top, my little b, and then on the bottom I have sine b equals my little c over sine of c. So I'm going to plug my stuff in, and I would have, let's see, 24.7 over sine of 28.7 degrees equals, I don't know what c is, and then I'm going to do sine of 102.3 degrees. Now, to make this easy for myself and for you, when we type it in the calculator, I'm going to cross multiply and solve. So you're going to have these two and those two. So what we have is c times sine of 28.7 degrees equals 27.4 times sine of 102.3 degrees. I want to solve right here for this c. So to do that, I'm going to divide both sides by my sine of 28.7 degrees and sine of 28.7 degrees. Please note that nowhere in this have I once dropped my degree symbol, and that's very important because you're going to need that in a second. So if I write this one more time, it's going to say that c, my little side c, is going to equal 27.4 sine of 102.3 degrees divided by sine of 28.7 degrees. And that's exactly how you're going to type it in your calculator, with your degree symbol and everything, because then it won't matter what mode your calculator is in. So type it. You're going to press Control Divide. Hey, let me draw you a little thought bubble. Have a little thought. You're going to do Control and the divide symbol, and that will make that fraction thing show up on your calculator screen, and then you can type that right into it. So let me do that really quick and get you an answer. And when you type it in the calculator, it should look something like this. Looks like this, and so that's our answer right there. Let me make the screen smaller, put it up here for us. So our answer ends up being that little side, oops, I should be in red. So little side C should be 55, remember we always round to 3 decimal places, 0.747, story problems need story answers, feet. So this side down here is the 55.747 feet. And now we have to still find A. So let me shrink all this down. Let's see if I can move this up a little bit. Make that a little bit smaller. Okay, so let's do A in green. So if I want to find angle A over here, big A, I hope you remember that on a triangle it adds up to 180 degrees. So I can do 180 minus the 28.7 degrees that I had for angle B, minus the 102.3 degrees that I had for angle C, and that should give me angle A. So in your calculator, you type 180 minus the 28.7 minus 102.3, and so you're going to find out that angle A is a nice even 49 degrees. So angle A in here equals 49 degrees. And now we need to find side A. So to do that, I'm going to do, oops, hang on, erase that. Not enough room. Let's try that one more time. I'm going to do, I want to find side A over sine of 49 degrees. And this is just a word to the wise. I am not going to use the ratio for C, because this C right here, over here on the side, it was rounded. And good math and science practices are that you don't use a rounded answer to find another answer because you're introducing more error. So I'm going to keep using B because that answer was given to me. I know that it's right. So even if I messed up side C, it wouldn't impact side A. So we know that side B was 27.4 over sine of angle B, which was 28.7 degrees. Again, you're going to cross multiply. So we're going to have A sine 28.7 is going to equal 27.4 sine of 49 degrees. and you're going to divide by this sine of 28, oops, forgot my degree symbol, 28.7 degrees, and divide by sine of 28.7 degrees, and then you're going to type this piece right here that I'm boxing in your calculator, and you're going to get side A. And when you do that, you should get, remember, 3 decimals, you should get the answer is 43.061 feet. I'm going to go label that on my triangle. So my little A over here is 43.061 feet. So what you're going to do now is you're going to pause the video, and you're going to read problem number 2 and try it. If you can't draw it, then you're going to press play on the video so that you can at least see the picture. It says that the pole tilts towards the sun and the shadow has to be under the pole, so I hope that helps you draw it. And then you're going to do the math to find the missing side and then check your answer. So pause the video and try to draw it, then press play and check that your drawing is right, then pause the video again and try the math, and then check your answer. Okay, so it says that I have a pole that tilts towards the sun, so my flagpole is tilted towards my sun. And then it says the angle of elevation, oh, sorry, hang on. It tilts towards the sun at 8 degrees from the vertical. So let me use, I'll use green. So here's my vertical right here. That means this angle in here is 8 degrees, which means this angle down here should be 82 degrees, because it should add up to 90 degrees to my right, make a right angle. It then says that the shadow's 22 feet, so my shadow down here is 22 feet long, and that it wants the angle of elevation from the tip of the shadow to the top of the pole. So I'm going to use this in red. So from the tip of the shadow up to the top of my pole. So what I'm looking for in here is this angle that I'm going to call, we'll call it a big B. So let me draw this one more time for you. So what I have right now is a triangle. Horrible drawing, I know. This is 22 feet. It was my shadow. This angle in here is 82 degrees. And I don't know what angle B is, but I'm going to find angle B. So what else can we label on this triangle? Well, we could label this piece right here that says, right here, that it's a 43 degrees. So we know that B is 43 degrees. So now I can go in here and erase, I'm going to erase the B. And we're going to write 43 degrees in here. And it wants to know, how tall is the pole? So now I'm looking for this length over here. If that was little b, then we'll call, or that big B, this is little b. So let's see. Well, I don't have, well, I have one complete ratio, but it has a variable in it, but I definitely can find this other angle, and I want that so that I have a complete ratio right here. So 180 minus my 82 minus my 43 degrees will find my angle up here that I'm going to call A. So when you do 180 minus 82 minus 43, you should get that this angle up here is 55 degrees. And now I have a complete ratio. So if I want to find little b, okay, so we know that we want to find little b, and its angle, friend, is sine of 43 degrees. I'm going to use my ratio of A and A, so I have 22 feet over sine of 55 degrees. And so you'll do your little cross multiply, make a butterfly. And so you'll have 22 sine of 43 degrees equals B sine of 55 degrees. And so when we solve for this, we're going to have 22 sine 43 degrees over sine of 55 degrees is going to equal my side B. Make sure you put the degree symbols in and type it in your calculator and see what you get. So you should get, again, 3 decimals, that B equals 18.3 .317 feet. So that's how tall the flagpole was. We're going to do 2 more problems that are on page 46. Okay, so let's look at this. So every time you've ever found the area of a triangle, you have always been told that it's 1/2 base times the height because you knew what the height was. But we have oblique triangles, we don't know the height. So let's go back real quick. I want to look at this. So if we were doing 1/2 base times height, we always gave you this 90-degree angle. We gave you some oblique triangle. We called this the base. And we always dropped down the height for you and told you what the height was. But if we were trying to find the height, depending on how the triangle was labeled, it would be called B sine A. We'll go down here. It could be B sine C, C sine B, C sine A, any of those combinations. But if this angle in any of these formulas was 90 degrees, like it would be right here, then that piece of the formula would go away and you'd be back to your 1/2 base times height formula that we've always told you. But we are now with oblique triangles. We are not going to give you the height. So to do this, we're going to use any version of this formula that we want, any one of them. They're all equivalent. They're all exactly equivalent, and they're just changed based on how the triangle is labeled or drawn. The key here is that we have what's called an included angle. So let's draw what they tell us. They say that I have a triangular lot. Oops. I have a triangular lot. And it says that I have 90 meters on one side, 52 meters on the other, and it says the included angle. To be included means to be a part of, so the included angle is the one right here in the middle, 102 degrees. So what they're really saying in this formula up here, as long as you have a side angle side case where the angle is included, then you can use this formula. It wants you to find the area of the lot. So the area is going to be equal to 1/2 side times my side times sine of that included angle in here, which we called A. So area is going to equal 1/2 times my 90 times my 52 sine of 102 degrees. Don't forget to type in your degree symbol. So I'm just going to grab a calculator. I'm going to type 1/2 or 0.5 times 90 times 52 times trig and then press sine of 102 degrees. And your answer should be that the area is equal to 2,288.865 feet. Nope, not feet, meters this time. Change the label. Let's write that one more time. 65 meters squared. Story problems have story answers, so don't forget your appropriate label. So now you have finished this whole lesson. You can go back to Canvas and do any one of the practices you want, and you can also look at that Canvas page where you found this video, and there are extra practice problems if you would like to work on them. If you have any questions, remember to visit your teacher during office hours or send them an email.